So, good evening, everyone. So, this is the topic that we are going to deal with. Okay, save data using SQLite. So, we will see how we can create a database using SQLite, how we can update that data. Okay, and what are the techniques to do that, and what are the commands that we are supposed to run. Okay. So first of all, if we talk about a database, data and SQLite, you can just imagine that your database consists of a table, okay, and we are talking about relational database. We're not talking about other databases, and we are talking about relational databases. In relational databases, you say that okay, in database you have tables, and in the table you have data, okay, corresponding data. For example, the green table is going to get the green data, okay, and the orange table is going to get the orange data. So in order to access this kind of data, okay, or in order to maintain this kind of a data, you have a SQLite package, which is stored inside the database package and which is further down there in an Android package. Okay, so saving data to database is ideal for repeating or structured data. Okay, if you have a data which is recurrent, like for example, you in your Android application, you have multiple activity screens, and on those multiple activity screens, you want some kind of a data which is persistent across all these screens. So that's a kind of a data which is repeating data. So it's better to store the data inside the database. Okay, and structured data, if it has some structure, okay, there is a non-structured data, unstructured data, there is a structured data which has some kind of a format, okay, format, like for example rows, and which can be configured into rows and columns, such for example contact information, if we talk about. Okay, but before making use of the SQLite, if you are thinking that okay, you can maintain a database in SQLite, you can access it directly, there is a word of caution. In fact, there is not a word of caution. There are four sentences of caution. Okay, the first caution is although SQLite package APIs are very powerful, but they are fairly low level and require a great deal of time and effort to use. Okay, and moreover, the another caution is there's no compile time verification of raw SQL queries. As your data graph changes, you need to manually update the affected SQL queries. And this process can be time consuming and error prone. Okay. So it's like you have to do a lot of job. Okay. Because it's not going to tell you at a compile time. There's no compile time verification of the SQL query that you're going to type. Okay. And another caution is that you need to use a lot of boilerplate code to convert SQL queries and database objects. So that means you have to write a lot of code, okay, which is generally not advisable. And this is the reason that room persistence library usage is highly recommended to access information in your app SQLite database. So you can easily figure out from this diagram that if you want to make a request to access a database, or request to delete a database, or request to any kind of accessing thing to a database, make that call to a room persistence library. Okay, and that room persistence library will make that interface to your SQLite. Okay, so you can imagine that. Look, you can here see that. Okay, see here, if I go to the last slides, so this blue caution, this green caution, this somewhat other let's say mustard color caution, they are mentioned at the top of SQLite, just to say that these are some of the cautions that you need to exercise if you are accessing SQLite directly. Okay, and for that matter, just to avoid getting into these traps, just to avoid the difficulties that you might be facing if you access SQLite directly. Okay, so it's better to use this room persistence library. So make a request to room persistence library. This room persistence library will get the data for you. Okay, and response you will get through room persistence library, and this is the recommended practice for Android developers. Okay, let's define the first thing that if you are going to think about, let's say I'm going to create my database for my Android application. Okay, the first thing that you need to do is you need to define a schema, and you need to define a contract. So first of all, you need to know what is a schema and what is a contract. Only then you will be thinking of designing them. Okay, schema is one of the main principles of SQL databases. It could be any relational databases. Every database has a schema, and schema is about how your database is organized. Okay, for example, how many tables are there? Okay, what is the relationship among these tables? One table might be related to another table in one-to-one relationship, one-to-many relationship, many-to-one relationship, or vice versa. Okay, so that is a thing that you need to chart out that organization. Okay, let's just imagine. Okay, may use my annotation to do that. Okay, let's just imagine this is one particular table, and in this table there is some key which is your primary key. Okay, and this table is connected to, is related to another table, and this primary key is also present in another table, but that primary, that is not a primary key there, that's a foreign key over there. Okay, that's a relationship. And if you say that table this table, let's say this is A table, okay, and this is B table, and this A table is related to B table in one-to-many relationship. So you can imagine creating your diagram, ER diagram, entity relationship diagram, something like this. That this table has, let's say for example, just imagine that this is a student table. It contains the information about student, and this is for the courses table. Okay, so that means one student can have multiple courses. Okay, so student enrollment number here and student enrollment number is also figuring out here, just to say that this particular student is going to have these many courses. Okay, so this is a kind of a schema. So it's if you're creating a database for the entire university, there might be other tables as well. Okay, so you need to chart out the tables. So that chart out of a table along with the relationship that these tables have, okay, among themselves. Okay, this table might be connected to this table. Connected means it might be related to this table, right? So that kind of a schema that you need to have, this kind of a thing, if you draw, okay, and this is a schema that you need to have at the very first time. That means you need to know what, how your database is organized, and the collection of tables is the only thing that we call a database. Okay, and if we add one more layer to it, to this database, and if we say, if we store some APIs into it, let's say how to delete a data into the database, how to access the data into a database, then the database becomes database management system. So you have a management system which also contains the APIs so that you can manage the database. Okay, so that is a schema thing. So this schema thing is done. Okay, now in order to support this schema, you might be interested in designing a contract class that is a companion class. Okay, and this contract class, okay, in order to understand the contract class, just imagine that this is a container class. Okay, and this looks like a container. It looks like that you have some kind of container. Okay, that or lid is mentioned as a container class because it says that this kind of a container contains constants. Okay, so this CURI stands for constant for URI. C table A column D stands for that this is a constant that represents a column D of a table A. This C table A represents a column. This represents a constant of a table, constant of table A. Okay, there could be many tables. Let's say, for example, that's why I have written down multiple black things. So black things are for, just imagine that this black thing is representing a constants that represent a table. Okay, and these blue things are representing constants that relate to the columns, and these green things are used for representing constants that represent URIs. Okay, so container class is a collection of these constants, okay, that define URIs. So here it is mentioning it defines URIs, okay, it defines tables and defines columns, okay, and the purpose of the very purpose of defining a contract class is that if you have this kind of a container class, then you can supply this container class to provide the same constants to the various classes in the package. Just imagine you have a package, okay, that you're maintaining in your code, and in your package you have multiple classes, and all of the classes wants to use your container, the constants which are there in a contract class. Okay, and the advantage of this whole thing is that if you make change into, let's say, into a column, okay, if you make change into a column, and that change into a column that is represented by this constant of a table A column D will be reflected across the classes. Okay, you don't need to go to entire individual class to update the thing. Okay, so a change in one place gets reflected in other places as well. So this acts as a global thing. Okay, so in a later slide we'll also see how to design this contract class, how, what is the configuration of a contract class, how this contract class looks like. Okay, we'll take an example to elaborate more onto it. I hope this thing is clear to you. So you need to define, you need to know these two things: schema and contract. Schema is all about organization of your database, and the contract is all about the container class that contains the constants. Okay, and those constants can be supplied across the classes of the package. Okay, let's see what it has to say in the next slide. Okay. The next slide says that this is representing a good way to organize the contract class. Okay, this tells you how your contract class is organized. Okay, like schema is for organization of your database. Okay, contract class is all about the constants. Okay, and there are some constants which represents the global definition. Like for example, if there are constants which represents the global definitions, like for example, if a URI is global to your application, okay, one particular table is also global to your application, put that at the root level. Okay, so put definitions that are global to the whole database in the root level of the class, and then you need to create some inner classes for each table. Okay, suppose you have 5 tables, you need to create 5 inner classes for them. Okay, each inner class enumerates corresponding table names. So you can imagine that, yes, you just imagine that you have 2 columns. So just imagine that you have 2 tables in your database, table A and table B. Okay, and these protruding images represents the enumerations of the columns. So let's just imagine that table A has 4 columns, so 4 protruding images on top of that. Table B contains 2 columns, so 2 images on top of that. Okay, so let's see how would it look like if we incorporate these changes into a contract class. So this is how it is going to look like. Okay, so let's just go. So this is how it is going to look like. So what we're going to do that into contract class, we'll be taking global definition that we talked about in the last slide. So, okay, so this is at the root of the contract class. And then you have some inner classes. Let's say you have two tables, table A and table B. Okay, this is the hypothetical graphical image so that you remember what is in a contract class. If you think of a contract class, just think of this image. Okay, everything will get into place. And this is a piece of a code that you can think of how contract class is going to look if you're talking about a code. Okay, so this contract class, let's say here, okay, this feed reader contract represents your contract class. Okay, so this is your contract class, and this and to prevent someone from accidentally instantiating a contract class, make its constructor private. So here you have made a constructor private, and you have not written anything in the constructor, so you just opened it and you just closed it. Okay, just this was just to say that, okay, your constructor has to be private, so that accidentally nobody should be able to instantiate a contract class. Okay. Okay, then I told you that after this whole global definition, so this, just imagine that this you have, if you have certain variables, certain constants which are globally, we talked about constants for representing representing the table, representing the columns, representing the URIs. Like those constants can be represented at this place at the root level, and after that we talked about that you have to have some inner classes. So this is the class that we were talking about. Okay, like for example, here we were talking about a feed entry table. Okay, feed entry table, and just because it is that particular class which we are doing, feed entry, we have to, we have to make it implement some interface that's called base columns interface. So that base columns interface, due to base columns interface, your table is going to have the default primary key, that is _id. Okay, base column interface is just because the inner class for a table is implementing the base column interface. Okay, it is going to have that _id is defined there in base columns interface. Okay, so that's why it's written as implements base columns. Okay, so you're mentioning that in this table you have 3 columns. Okay, the table name is feed entry, this is the name of a table, and it has three columns. Sorry, 2 columns. It's not 3 columns, or 2 columns. Okay, table name is entry. Okay, table name is entry. The class equivalent of that is feed entry. Okay, DAO is relationships relating a table with the class objects. Okay, here the name of a table is entry. Okay, and the column title, and the 2 columns are there. One is a title column, other is a subtitle column. Okay, and the values are passed to it. Okay. Not values exactly, but these are the table. This is the table name, and this is the name of the column title, name of the column, and this is another name of the column. Okay. Here you are not supplying the values. You are supplying that this is going to be the name of a table. This is going to be the name of a column. First column will be called title. Second column will be called subtitle. Okay. So you just can imagine that we are talking about a table. Okay, let's say you are talking about a table, and in that table the name of a table is entry. Okay, and you have two columns in that. Okay, one is entry, other one is title, other is subtitle. So this is for title and this is for subtitle. Okay, let's move down. So this represents your contract class, I told you. Okay, global definitions and then error classes. Okay, let's clear this and let's move forward to see what we have. Okay, so once we have defined the schema, okay, once we have defined the schema and we have also defined a contract class, okay, the next thing is to create a database using a SQL helper. Okay, so here we are using a SQL helper, and once, let's say, just imagine that your database is created, your Android system is going to store your database in a private folder. Okay, and that private folder will make your database secured, and that private folder will not be accessible by other applications. So you can imagine that this is a private folder and there is a database inside. Okay, and in that database there are the tables. Okay, there could be multiple tables, there could be multiple, you know, these kind of things. Okay, and this lock represents that your folder is private. Okay, and this kind of a code, okay, this says that, okay, you are defining here, what you're defining, you're defining two strings. One is SQL underscore create and underscore entries, another is SQL underscore delete underscore entries. So this, you are creating two strings, and one string is for a create table command, other string is for a drop table command. Okay, so this SQL underscore create underscore entry is going to contain the create table command. So what's the name of a table? You have a contract class, fetch that name from a contract class. Okay, not a contract class but the inner class of a contract class. Okay, contract class is feed reader contract, inner class is feed entry. So inner class represents a table and it enumerates the columns. So it is the enumeration of columns, two columns are there. Okay, so fetch the name from the inner class of a contract class, feed entry dot and table underscore name. So it will fetch the value from here. Okay, that is entry, create table, then mention the name of a table, and then start the parenthesis, mention the column name, and specify the type of a column, that is integer, and specify that it is a primary key. And we know that our inner class is implementing that base columns interface. Just because it is implementing that base column interface, you're going to have an access to underscore id. Okay, so we have already have a column which is being treated as a primary key. Okay, so this is an integer and it is a primary key, comma, concatenated with the other thing. Okay, that other thing is the name, mention the name of a first column and mention the name of a third column, sorry, the second column. By default the first column is going to be the primary key. So you just can imagine, in the earlier slide I mentioned, I drew two columns, but in fact there are three columns. One column is default. Okay, and that default column is thanks to the that interface, base column interface. Okay, so there are three columns. Okay, so the first column is going to be id, this is going to be the first column. Okay, default column, this is going to be this second column. Okay, this is going to be the third column. Okay. Okay, now this is not going to create the table, but this is just going to initialize a string, because we have not fired a command to run this command. Okay, this is just, you have just stored the SQL query of a create table into a string, and here also you have stored a SQL query to drop a table. Okay, which table? Drop table if exists. Which table? This is the table name. Fetch the name of a table from the inner class of a contract class, and that inner class is feed entry, which implements that your which class it is going to implement. Base columns is going to implement that these columns interface. I hope you are getting it. Okay, so anticipating that you are getting it, okay, I'm moving forward. Okay, so we were talking about here in this slide, we talked about using SQL helper, but we have not used a SQL helper. We have just, in this slide, we have just created two strings, okay, but we are yet to call SQLite Open Helper. So SQLite Open Helper is a class, okay. That class contains useful set of APIs for managing your database, okay. If you want to get a database for a writable purpose, you need to call this get writable database. If you want to get a database so that you can read from a database, and this is a call that you need to make, get readable database. And these calls are, these methods are the methods of this class, SQLite Open Helper class. Okay, so when you use this class, okay, there are many advantages if you make use of this class. One of the advantage is that if you make use of this class, system performs the potentially long running operations of creating and updating the database only when needed and not during the app startup. It's not like you just opened up your Android app and database connection is made. No, database connection will only be made, database operations will only be done if they are required. If they're not required, that connection is not going to be established. Okay, and all you need to do is to make a call to this function. So that's why it's like you need to make a call. That's the reason you see speaker over here, because you're calling get writable database here, get readable database. So it'll get you, they will get you, you know, the instances of the databases in writable mode and readable mode. And now one more caution that you need to exercise, that these make these calls in the background thread only, because they are long running processes. Okay, and if you do not do this, if you make these calls in the foreground thread, okay, it might hinder the activities of your application. So make it a point that you make these calls in the background thread. Okay, and yeah, as already talked about, that SQLite Open Helper contains a lot of useful APIs. So you can just imagine that this is a bunch of this is a collection which contains bunch of APIs. So you can just imagine that these are some of the contents of the SQLite Helper, which says that okay, these are APIs. Okay, and these are the purpose of APIs. Purpose of APIs are to manage the databases. I told you initially once you have a database contains the tables, you need to add extra layer to that, and that extra layer is the set of APIs that helps you manage database. Okay, that makes database management system. Okay, so let's use SQLite Helper to create tables. Okay, so here in this slide, you are doing what? You are making use of the SQLite Helper. So here you can see, let me just use this. Here you can see this is a SQLite Open Helper we were talking about, that we are making use of it. Okay, so we are creating a subclass of it, and that subclass is feed reader DB helper. Okay, so we are making use of this feed reader DB helper, which is extending the SQLite Open Helper. Okay, and in this class, okay, what we are doing, so before explaining this thing, let me just tell you that you need to make these things into your mind, that you already have two strings. One is that stores the creatable query, other is that stores the drop table queries, because these strings we are going to make use of in the later slides. Okay, like here you have two public variables. One is integer, other is database name, and their final. Okay, database version, this is the first version of your database. Okay, and this is the database name is feedreader.db. That's the name of a database, and here you have called a constructor of that. Okay, and that constructor is going to call the constructor of SQLite Open Helper. That's a super class, super method you have called. And in the onCreate method, okay, so you need to override this onCreate method, okay, to run your SQL underscore create underscore entries. So this was the thing that I was talking about. This is the string that you just created, okay, that you created for that contained that create table query. Okay, so this exec SQL command is used to execute that SQL. Now here that table will be created. Okay, those entries will be those entries in the database, not exactly the entries, but the table will be created. Okay, so because SQL underscore create underscore entry stores the create table command. And then there's another method called on upgrade method. So on upgrade method, the upgrade policy is, for example, this kind of a database that we're talking about, it is like a cache table. Okay, so even if you delete a table, if you drop a table or a delete a table, like here SQL underscore delete underscore entries is going to drop a table. We saw that in this variable, like here it is a drop table if exists. Okay, so when if I drop the information from a cache, the actual information stays there in a server, right? So it's so that's why in the on upgrade method, okay, what did you do? You just executed that SQL command that corresponds to drop a table, because this database is only a cache for online data. So it's upgrade policies. So what do you do want to do? Upgrade in that upgrade, you call that method db.exec SQL. Okay. So in the on create, when this SQLite helper method got initialized, okay, so this is not method exactly, but when the on create, this is an on create method of your feed reader DB helper, which is the subclass of SQLite open helper. When it is created, okay, you created a table, and when it is upgraded, okay, when you call on upgrade, the table was dropped. Okay, and then you might also want to implement downgrade, but it's not required. We're not going to talk about it at the moment. Okay, so let's access our database. Just imagine that we had, initially we fired our we made our weapons ready. I mean, we made those uh, strings in which we stored our queries. Then we called SQLite open helper, okay, and we created a derived class of that, and we fired methods of on create. Okay, we overrided those methods on create and on upgrade. Now imagining that we have a database created, and let's say we have not dropped that table. Just imagine that we have created a table inside a database. So accessing a database means accessing a table inside the database. Okay, so access your database, what you need to do is you just need to instantiate your subclass of SQLite Open Helper. And we know that the subclass of SQLite Open Helper we created in the last slide, that is feed reader DB helper. Okay, so you just create that. Okay, so that will be created and it will enter into its life cycle. Okay, and as it enters into its life cycle, there will be on create method which is going to be called. Okay, and the moment the thing that you are going to do with that object, it will keep on entering into its life cycle states. Okay, so this is the command, okay, that is used to instantiate the subclass of SQLite Open Helper. And in this way, you will be able to access your database through DB helper. Now, in the future slide, in the further slide that are going to come, we'll be referring to this DB helper to access the database. Okay, so let's access our database and put some data into it. Okay, we know that how to access a database and how to put the data into it. There is an insert method to do that. Okay, so insert method is like an insert query. Okay, so actually it's an insert query, but here in Java code, okay, we are writing an insert method so that it can be converted, boiled down into the insert query. Insert the new row, returning the primary key value of the new row. So the insert query is going to take three arguments. The first is a table name. Okay, what table name? What is the table name in which you want to insert a row? And then the second argument is going to tell you what to do if a table is empty. Like here you can see that there are three arguments to it. First argument is fetching a table name from the inner class of a contract class. Okay, and this null specifies what to do when a table is empty. Now if you specify null, okay, row is not going to be added. But if you specify the column, okay, let's say just imagine that if you are specifying the name of a column over here, that means this criteria, the second argument, is all about what to do if a table is empty. So if you specify the table, it'll insert the row with the null values, okay, in the corresponding column. It will insert the row with the null values. Okay, so this values is going to be the map. This values is a map, okay, which creates the key and a value. I mean, this value says that, okay, which column is going to get the which value, which column is going to get which value. Let's say in our case, we know that in our case we have a table. We're talking about a table where there are only three entries. There are three columns. One is default primary key, other is title, other is a subtitle. Okay, and so this values is going to be a map, okay, which is going to contain the values for for all the columns. Okay, we'll see how to do it in the, and the complete picture is this is the complete picture. Okay, and this complete picture where you can make sense out of this value. What is this values are content values. Okay, this is a map of values, so you can say that this is a kind of a dictionary. Okay, and here you have entered values into it, values.put. So specify the name of a column and specify the column title, and then specify the title. Okay, title, this is a variable, right? Variable which contains the value that you want to put. Okay, and this is another variable subtitle that is supposed to contain the value that you want to put as a subtitle. Okay, feed entry dot column name underscore title, that means this is the key of this. In this map there are two values. The first value contains, this is the key to that, and this is the value to that, and for the second entry this is the key to that, and this is the value for that. So once that map is ready, okay, you can put that map as the third argument of the insert. So here you have entered as a, you have put it as a third argument, that is values you have put over there. Okay, this argument says what to do. So in this case, null is written, that means the row is not going to be inserted. The first argument is you need to mention the table in which you want to insert the data. Okay, that's the complete picture. And the next thing is how to read in information from a database. We just saw that how to insert in information. Now we are seeing that how to read in information from a database. So in order to read a database, okay, read in information from a database, what you're going to do is you will be you'll be calling a query method. Okay, and query method is like select. How do you get a method? How do you get a SQL? You might be knowing the SQL command for reading the data, and the SQL command is select. Okay, select, then you need to mention the name of a columns that you want to fetch. Okay, from the table name that you need to know. Okay, and then you also specify some where clause. Okay, so the similar thing that we are going to map over here. The first thing that it has, the query method is going to get the table name that you are expecting to get value from. Okay, the second argument is an array of columns to return. That is sometimes called projection. So you can, over here, you can look at it. Let me use a spotlight to highlight this. So the first thing, just imagine, just concentrate, just forget about what is written over here. Just concentrate over there, over here. So we are talking about the query method, query method of our database. Okay, so first thing is you need to mention the name of a table. So here is the name of a table. The second is the array of columns to return, that is projection. Okay, and now pay an attention over here. Now here the projection, this is the array of columns. Okay, I want an ID, I want an ID of a base columns, right? Base column is an interface. I did not write feed entry because ID is not a member of feed entry. ID underscore ID is a member of base columns. I told you that base columns is an interface that your class is going to be implementing. Okay. So then feed entry dot column underscore name underscore title, feed entry dot column underscore name underscore subtitle. I want to project all these things. Okay. And you could also specify null if you want to get all. Okay, like you could also specify, there was no need. If you are wanting, if you want all the columns, okay, you can also specify null here. But if you, let's say, you want to specify just one, you just interested in only one column, you specify that column in the array, or two column in the array. Okay, and here the third thing is you need to specify columns. Okay, and values for the columns. Okay, like here it's an array of columns. Here you are selecting the columns for the where clause, columns for the where clause, and values for the where clause. Like where the value of this column is this. Fetch all the fetch all the columns. Select star from table where let's say roll number is this. Okay, that roll number. Okay, and this is selection. This is selection, and this is selection arguments. Okay, selection, the columns for the where clause, and this is values for the where clause. Okay, and then this, you can say this null, this says that okay, whether to do the grouping or not, and this null says that whether to do the filtering or not. Okay, and this argument says that what is the sorting order. So here that's why it's written group or not to group, filter or not to filter. Okay, and sort order. Okay, now you can see that the projection I talked about here, your projection is about the array of columns that you want to extract. Okay, and selection is about the column name underscore column underscore name underscore title. Okay, and then you write a question mark is equal to question mark. Okay, that means you want to ask the user. Okay, question mark is used when you want to ask a user. Okay, placeholder. Okay, and then you are using the arguments, and this is an argument to that, where the column title is my underscore title, my title. Okay, that's the value that you're looking for. And sort order is descending. Okay, this is a column name for that. You want a descending order as respect to this column, that is subtitle. You want to actually see the data. Okay, that in a descending order of your subtitle. That's a sort order we were talking about. And the result of this entire query is stored in a cursor. Okay, so that cursor is a kind of record set. Okay, that is going to show, that is going to store the data, entire data that is fetched as a result of the query. Okay, so let's see what we have after this. Okay, so you know that here we mentioned that the columns, and that means where clause, we specified where clause by separating the values out. Okay, we could also used one, we could have also have used one particular variable to specify the column and their values. We could use map also, but we did not use map just to escape from a SQL injection, because the arguments are provided separately from the selection query. They're escaped before being combined. Okay, so though internally they are combined, columns and the values are combined internally, but before being combined, okay, they are escaped. Okay, they are escaped. This makes your selection statements immune to SQL injection. We'll be talking about this SQL injection, okay, in some other lecture. Okay, at this moment we're not going to talk about this. Cursor. So let's talk about cursor. So this cursor is the output of that query method. Okay, I talked to you that cursor is going to you can iterate this cursor, you can navigate this cursor. Okay, you can iterate this cursor to fetch the value, to see the values, to view the values what are being fetched. Okay, now in this particular piece of a code, what is being done is, so you have an array list. Okay, array list that is item IDs. Okay, and you are populating this array list with the primary key values of the table. Okay, and then you can over here you have used move to next method of a cursor. Okay, like you have the data inside the cursor, and you are using move to next method so that you can, while the loop starts, okay, so it will point to the first item of the row. Okay, and the first item of the row is your underscore ID, your primary key. Okay, and you want to typecast it into long. Okay, because this is the long thing, so you call the getter method of cursor dot get long. Okay, and in that case you use the method get column index or throw, because you want that if this is not feasible to, if there is some problem, you want to throw an exception. So cursor dot get column index or throw, you call this method, so that the value of the variable, value of the column, which is a primary key, okay, will be fetched and will be converted into a long. Okay, and once it is converted into a long, it is fed into the item ID. Okay, and then you have added that item ID into an array list. Okay, and this is an array list, and then one more iteration. Okay, and this while loop will keep on moving as long as there are items in the cursor. Let's say a cursor fetched 5 values, because there are 5 values which satisfied the criteria that you mentioned. Okay, so this while loop will run for 5 times. So at the end, your array list is going to contain 5 items. Okay, and at 5 items, five your primary key values. And once you are done, don't forget to close. Okay, let's have a look at what are the dialogues of this cursor. So this cursor says that you can use my getters like get string, get long, etc. method to fetch the corresponding column values. Like here we have used only get long, but it could be the case that there are certain columns in the database, in the table, which are of a string type, which are of some other data type. So there are corresponding getters available in the cursor method. Okay, there are cursor methods available. Now in this code, it's saying that I'm just being used to fetch primary key values of each row into the array list called item IDs. Okay, and it is requesting that please don't forget to close me once you are done exploring fetched data. That's the reason it is mentioned over here, cursor.close. Okay, let's see how to delete information from the database. Okay, how to do that. So there is a delete method, like To fetch data, there is a query method. To insert a data, there was an insert method. Similarly, to delete a data, there is a delete method. Okay, so you just need to do three things. You need to specify the table name from which you want to delete the information. You need to specify the selection criteria, and then you fire the delete method. That's it. Three simple things. Okay, A, B, C. So first of all, you specify the selection criteria. Here you specify the selection criteria. Okay, and you are getting the selection criteria is equal to string selection is equal to feed entry dot, that's an inner class, dot column underscore name underscore title like. Okay, so that means you're talking about that where column title like the value, and this is the value. Okay, value of the selection and selection args. Okay, once you have specified the selection criteria by using these two things, okay, then you specify the delete method, deleted rows, and it's going to get you how many rows are deleted. That's why the return type of this delete method is integer. Okay, and deleted rows is going to contain the number of rows which are deleted. The first argument of the delete method is the name of a table. Then the second and third method are separated, selection and selection args, something which is related to avoiding the SQL injection. Okay, update a database. Okay, so in order to update a database, you need to combine the content value syntax of insert with the where syntax of a delete. Okay, so here you can see that you have from a DB helper, you got, I told you that you need to make a call. Like, for example, you want to update a database, that you want an instance of a database which you can write into. So you need to make a call to get write able database. Okay, you have made a call over there. Okay, and yes, you have first of all get ready with the value that you want to update. Okay, that is a title that you want to update a table, update a value. Let's say my new title is the value that you want to set to the title. Okay, and then you prepare that content values. That means you prepare something, prepare the value that you want to feed into the database. So content values, it says that okay, I'm going to, it's a default constructor. So once you have defined the content value, it's like a map. Okay, so map, if it is a map, you need to enter a key and a value. So key is column underscore name underscore title, and the value that you have defined my new title. So specify that over here. Okay, and then this is not done. Okay, this is just, you just have prepared values. Okay, then which row to update? You need to mention which row to update. That means selection criteria. String selection is equal to feed entry, the inner class dot column underscore name underscore title like question mark. Okay, then you specify my old title. Okay, that means your column should look like my old title. So update my new title, update the title to my new title, where the old title, where the title was my old title. Okay, so where the title was my old title, it will be updated with my new title. Okay, and then you here you do the updation thing. Okay, so db.update, first of all specify the table name, then the values, that means the map you mentioned, then selection and selection criteria, selection and selection argument. So this is a simple syntax of making an update, and it is also going to return you an integer, and that integer is number of rows updated. Okay, so that, yeah, this is important. Sometimes see, we closed a cursor when we made use of a cursor. Okay, a cursor was also requesting please close me once you are done. Okay, we can close the cursor, but it is not advisable to close the database. Okay, because just imagine that we have closed a database and later on we need a database connection. Okay, so then firing that get writable database, get readable database are expensive, will be expensive in fact when database is closed. So it's better not to close the database as long as the activity is active. Okay, so just in order to make sure that the database connection is closed only when activity gets destroyed. Okay, write a piece of a code. Okay, write a piece of a code in the on destroy method. Here we have mentioned on the code dbhelper.close super.on destroy. Okay, in the on destroy of an activity. So it will make sure as long as an activity is active, your database connection is persisted. Okay, so that will avoid the complexity, the delay which is going to happen when you're making call get writable database, get readable database. And then you can also debug your database. Okay, Android SDK includes SQLite 3 shell tool that allows you to browse table contents, run SQL commands, and then you can also perform some other useful functions on SQLite databases. And the next lecture, okay, we'll be talking about the SQLite 3 shell tool. Okay, we'll be experimenting. That will be some kind of a practical session. Next lecture. Okay, that's it for today's session. I hope you enjoyed today's session. Let me just clear the whole thing. Stop sharing. Okay.